We're on lesson 4 of chapter 9, which we're going to use square roots to solve quadratic equations. So first we're going to solve quadratic equations, then we're going to solve special types of quadratic equations, then we'll solve a real-world problem. Today we're working with quadratic equations in the form of ax squared plus c equals 0. So if you notice, we're missing that bx in the middle here. When we have this in this special form, we could solve it in this way. So the first step is to isolate x squared. So you get x squared by itself. That gives you x squared equals whatever d is over here. If the value of d is greater than 0, then x squared equals d has two solutions, the positive square root of d and the negative square root of d. And that would look something like this, where you have x equaling positive 5 or negative 5. If x equals 0, then x squared equals d has only one solution. The square root of 0 is 0. And that would look like this, where it crosses only once at 0. If d is less than 0, then x squared equals d has no solution, because you can't have the square root of a negative number like this. So let's put this knowledge to use. So it tells us to solve the equation, 2x squared equals 8. Well, we need to isolate the x squared. So to do that, we could divide by 2 on both sides. So our new equation, x squared equals 8 divided by 2 is 4. So since 4 is greater than 0, it's going to have two solutions, the positive and negative square root of 4. Well, the positive square root of 4 is 2, and the negative is negative 2. So x could equal positive 2 or negative 2. Another way to write that is to say positive or negative 2, like that symbol. So this would be our answer, x equals positive or negative 2. Here we have m squared minus 18 equals negative 18. Well, if I'm going to isolate the m squared, I'm going to add 18 to both sides. So my new equation would be m squared equaling negative 18 plus 18 equals 0. So if I square root both sides, that would leave me with m equals 0. Only one solution. Here I have b squared plus 12 equals 5. So if I subtract 12 from both sides, that would give me b squared on the left equaling 5 minus 12, which is negative 7. If I square root both sides to answer, I'll realize that I have b over here, but no number times itself could equal negative 7, because you need a positive and a negative to equal negative 7. So this would have to be no solution. Now let's solve these quadratic equations. We have 4z squared equaling 9. Well, first I want to get z squared by itself, so I can divide by 4. So I have z squared equaling 9 over 4. So z would then equal the square root of 9, which is 3, over the square root of 4, which is 2. And it could be positive 3 over 2 times positive 3 over 2, or negative 3 over 2 times negative 3 over 2. So I'll have positive or negative 3 over 2. Now we have 3x squared minus 11 equaling 7. It says round the answer to the nearest hundredth. So the first thing I could do to isolate the x squared is to add 11 to both sides. So that would give me 3x squared equaling 18. Now I can divide both sides by 3. So that gives me x squared equals 6. Now I need to find the square root of 6. So when I square root these, I have x equals, square root of 6 is, round to the nearest hundredth, is 2.45. And then I need to do a positive or negative 2.45. Now I have 6 times x minus 4 squared equaling 42. First I could divide both sides by 6 to get rid of that 6 here. So we have x minus 4, that's in parentheses still, squared, equaling 42 divided by 6, which is 7. So for this one, if I'm going to square root this, I need to square root all of that and all of that too. So if I square root this, the squared goes away, so I'm just left with x minus 4 equaling the square root of 7, which is positive or negative 2.65. So as I get x by itself here, to solve for x, I need to add 4. So therefore x equals positive or negative 2.65 plus 4. So now I need to actually solve for both to get my answer. So positive 2.65 plus 4 is 6.65. So that's one of my answers. My other answer would be negative 2.65 plus 4, which would be 1.35. So here are my two answers for x for this one. Now we can solve a real-world problem. It says during an ice hockey game, a remote-controlled blimp flies above the crowd and drops a numbered table tennis ball. The number on the ball corresponds to a prize. Use the information in the diagram to find the amount of time that the ball is in the air. So here we can use our vertical motion model, the h equals negative 16t squared plus vt plus s to solve this one. So we want the final height to be at 17 feet, so h is 17. We still don't know the time, so it'll be negative 16t squared. We know the vertical velocity is going to be 0, so 0 times t. And the starting height is going to be at 45 feet. So if we rewrite this again, we'd have 17 equals negative 16t squared. We can get rid of this because it's 0 plus 45. We can create this like the equations we've been doing so far by subtracting 45 from both sides then. So that gives us negative 28 equals negative 16t squared. Let's get t squared by itself by dividing by negative 16. So if I rewrite my problem over here, I have positive 28 over 16 equaling t squared. So to solve for t, I could square root both sides. The square root of 28 over 16 is positive or negative 1.32 to the nearest hundredth, so that equals time. Well, I know that it didn't drop this ping pong ball in negative 1.32 seconds, so it would have to be 1.32 seconds for our total time.